All right, guys, going now to note 6-13. Okay, we're going to talk about factoring, but now we're going to do difference of squares. So just like yesterday, we're going to do some warm-ups and multiplying binomials times a binomial. So when I do x times x, this becomes x squared. And then x times -4 is -4x. Now moving to this one, 4 times x is a positive 4x, and 4 times -4 is a -16. The two middle terms will combine, and a -4 and a positive 4 cancel each other, so I have x squared minus 16. Okay, second one, 5m times 5m. This becomes 25m squared. 5 times 5, add your m's. 5m times -1 is a -5m. Moving to the 1 times 5m is a positive 5m, and 1 times -1 is -1. The m's combine, and a -5 and a positive 5 cancel to give me 25m squared minus 1. So my last example, now we've got two letters. 2 times 2 is 4, and then a and a make a squared. 2a times -3b, the 2 times -3 is -6, and then you have to keep your ab because they don't multiply and add together, so we just keep both of them. And then 3b times 2a, that would be a positive 6, and we write letters alphabetical, A, B, when I put them together. And then 3b times -3b would be a -9, and then b and b make b squared. Your ABs will combine, but a -6 and a positive 6 cancel, so this becomes a 4a squared minus a 9b squared. So if you noticed, I had all these terms, and there were 4 things, and the middle term canceled every time, so it just became a binomial. So this is what we call difference of squares. They're always going to be perfect square numbers, and they're always subtraction. Okay, so when you're working these problems, the first thing that you have to do is make sure that they are difference. Okay, that means it has to be subtraction, and they both have to be perfect squares. If they are, you are going to follow the rule to factor a squared minus b squared equals a plus b times a minus b. So just like up above, you're going to have one factor with a plus sign, one factor with a minus sign, but the same thing in the factors. And then we can check our work by distributing, but for sake of the video, I'll show it in class. I'm going to save time. Okay, so we're going to do odds today. That's what I want to go with. Okay, so odds. If I have a squared minus 4, the first thing you're going to do is you're going to set up two factors. One's going to have a plus and one's going to have a minus every single time. Okay, a squared will split perfectly because a has 2. So if I put an a here and an a here, if I add those, that becomes 2. That's how we get a squared. Now, for the 4, here's what you can do in your calculator. If you don't know what it is, you're going to press second x squared to get the radical and then put 4 in. And you get 2, so the square root of 4 is 2, so then I would have a plus 2 and a minus 2. Now, if I were to distribute this, I promise you I'm going to get back to this answer. I'm going to show it on this one, but not on any others. So a times a would give me a squared. A times -2 is -2a. 2 times a is a positive 2a, and 2 times -2 is a -4. These cancel each other out, so I have a squared minus 4, which gets me back to my answer. So this is my final answer. Okay, for number 3, the first thing we're going to do, we're going to open up those parentheses. Okay, it's a minus sign. These are perfect squares, so the square root of 81 is 9. So I put 9 in the first spot, a plus and a minus, and the way we split x squared is x and x. You would double distribute to see if they work. Okay, for the number 5, I don't have a minus sign. In order for this to work, these have to be minus, so this would be one of those prime answers. You can't do it. Okay, for number 7, okay, now I have a number with a letter. So I'm going to open up my two parentheses because it is subtraction. I'm going to take the square root of 9, and then I'm going to take the square root of 100. Okay, the square root of 9 is 3, so I'm going to put 3 with a b and 3 with a b, because that's how you split the letters, b, b. But the 9 is with it, so you also have to split it. And then the way 100 splits, the square root of 100 is 10, so plus 10 minus 10. If I double distribute, I would get back to this, which I showed up here. So if y'all want to see it again, y'all multiply it and check it. Okay, this is subtraction, so now I'm just going to check to see for number 9 if they are perfect squares. So I'm going to do the square root of 16 and the square root of 121. I get 4 and I get 11, so both of them are perfect squares. So therefore, I'm going to split the 16a squared with a 4a and a 4a, plus, minus. And for 121, I got 11, so I'm going to do plus 11 minus 11. For number 11, okay, you have 2 letters this time, not a big deal, but we're going to check our numbers first. So the square root of 4 and the square root of 25. The square root of 4 is 2 and the square root of 25 is 5. So when I set up in my parentheses, I'm going to have 2, and since it's an h squared, I put h, plus, minus, and then the 25 became a 5, and since it's a g squared, I put g and g. Double distribute, you're back to your problem, so there's your answer. Okay, going to the back, I have x squared, y squared, minus 1. Okay, the only number you have in this problem is 1, so you have to take the square root of 1, which is 1, so it works. Okay, so I'm going to open up my parentheses. Since the letters are connected, I put x, y together. I can't put a plus or minus sign in between them because that's not where the sign fell. And then I do plus 1, minus 1 because the square root of 1 was 1. For 15, it is subtraction, so I'm going to do the square root of 4, which is 2, and the square root of 5, which is not a nice number. So since this number is not a nice number, this is not a perfect square, so again, this one is a prime. Now, as your exponents get bigger, that is okay. So like this will start helping you on 14 and on. Okay, if I have k to the 6 minus 16, okay, the first thing I need to know is if 16 is a perfect square, which it is, it's 4. So I'm going to open up my parentheses because it is subtraction. I put k, and what you are going to do is half the 6. So we're going to take 6 and divide it by 3, which gives me 2. So this would be, no, said that wrong. We're going to take 6 and divide it by 2, which gives me 3. So this would be k to the 3rd and k to the 3rd. Because when you're multiplying, you want to add your exponents, so 3 plus 3 is 6. And then when we did the 16, we add 4 and we subtract 4. Okay, so for 19, I'm going to check my numbers. So the square root of 121 and the square root of 1, so 11 and 1. So I'm going to go ahead and open up my factors because it is subtraction. They were both square roots and they were 11 and 1. I'm going to put my plus and I'm going to put my minus, and then I have to split my r squared. So I do 6 divided by 2, which is 3. So this would be r to the 3rd and r to the 3rd. So when your exponent is like a 4, you just divide that by 2 and see what you get. Okay, examples with GCF. So now going back to the GCF lesson, first I need to see, so I'm going to do math over to number 9, and I'm going to type in 2 and 72, and I can divide a 2 out of these. When I take the 2 out, that leaves me with n squared minus, and that will give me 72 divided by 2 is 36. So now I have to check the 36 to see if it's a perfect square. And the square root of 36 is 6. So I keep my GCF of 2 and open up my 2 parentheses. The n squared will split n and n. One's a plus, one's a minus, and we found out that the square root of 36 was 6. So there's my final answer. Okay, for 23, I have a GCF, so let's check and see if 32 and 18 have a GCF, and they do, and it's 2. So I can divide both of these by 2 again. So I pull out a 2. Since they don't share letters, we don't pull out a letter. Okay, when I divide by 2, I get 16s squared minus 9u squared. Okay, now I just need to see, is 16 a perfect square and is 9 a perfect square, which both are, 4 and 3. So I keep the 2 and open up my 2 factors because it is subtraction. I'm going to have a 4 and a 4. I split the s and the s, a plus, a minus, and 9 became 3, and I split the u. And there's my final answer. Okay, for 25, I'm going to see what I can divide out. So I'm going to go math over to number, hit 9, 24, 54. I can take a 6 out. When I divide by 6, this gives me 4a squared, and this gives me negative 9b squared. Now I check to see if those are perfect squares. So the square root of 4 and the square root of 9, both are perfect squares. They're 2 and 3. So I keep my GCF of 6. I put a 2, split the A. Put a plus sign, put a minus sign, and then I put a 3, split the B. And there's my final answer. All right, for 27, okay, so math over to number, hit 9. We have 80 and we have 125. I can divide a 5 out of both of those. So when I divide out a 5, I'm going to also look because they both have an n, so I can also take out n squared. When I take out 5n squared, so 80 divided by 5 should be 16, and 4 minus 2 gives me n squared. I keep that minus sign. 125 divided by 5 should be 25. And 2 minus 2 cancels, so I don't have that n squared anymore. So now I check to see if 16 and 25 are perfect squares, which they are, 4 and 5. So I keep 5n squared, open parentheses. This becomes a 4n and a 4n for 16n squared, a plus and then a minus, and 25 became a 5. There's my final answer. Oh, excuse me. Okay, for 29, I need to see what my GCF will be first. So math over to number 9. 36, 9. And I can take a 9 out of both. Since I can take 9 out of both, I look at my letters. They both have a p. The smallest p is just 1. So I can take out 9p. So 36 divided by 9 is 4. And 3 minus 1 is p squared. Negative 9 divided by 9 is negative 1. And 1 minus 1 cancels. So now I just have to see, is 4 a perfect square and is 1 a perfect square? And yes, they are. So I take 9p, my GCF, and open up my two factors. The 4p squared will split to 2 and then split that p. Plus, minus, and the 1 is just 1 and 1. So there's that answer. We got one more example. Okay, for 31, I need to see if there's a GCF first. So we're going to do 16 and then 100, and I didn't do the right number. So math over to number, I did it again, math over to number 9. I forgot to type. And we're going to type in 16 and 100, and I can take a 4 out of both. I also look, they both have a k. The smallest k is just k. When I divide by 4k, 16 divided by 4 is 4. 3 minus 1 is squared. Keep the minus sign, and 100 divided by 4 is 25. 1 minus 1 cancels. So now I just look to see, press the wrong button, if 4 is a perfect square and if 25 is a perfect square, which both are nice numbers. So I keep that 4k and I open up two factors. The 4k squared splits to 2k and 2k, plus, minus, and the 25 splits to 5 and 5. Now, if you were to double distribute these and then multiply by that GCF, you would get back to your original answer. You're finishing the problems, and if you have any questions, stop and ask.